What if I told you that the elements that make you, me, all of us, aren't just a random collection of cosmic dust? What if they're organized by a hidden structure, a kind of cosmic bridge that connects the birth of stars to the chemistry of life itself? Look, we've all heard that beautiful phrase, right? We are made of stardust. It's poetic, it's true. But maybe it's more than just poetry. What if, buried deep inside that dust, there's a message? A kind of blueprint, written not in biology, but in the fundamental language of physics. Think about it. The universe has this huge periodic table, over 100 elements to work with. But life is incredibly picky. It only uses about a couple dozen of them. And for so long, the big question has always been, why these specific ones? It turns out the answer might not be in their chemistry, but in their deep, deep connection to how stars live and die. So, to find that answer, we need a map. Not just any map, though. We need the universe's own energy map. We're going to start with a curve you might have seen in a physics class, and we're going to watch it transform into something that looks a lot like a cosmic bridge. The key to this whole thing is a concept called nuclear binding energy. It sounds complicated, but it's really not. It's just a way of measuring how tightly an atom's nucleus is glued together. Just remember this. The higher the binding energy, the more stable the element. It's like the universe's ultimate stability score. And here is that energy map. This is a classic. You see it in pretty much every physics textbook. On the left, you have the light elements. On the right, the heavy ones. Everything in the universe wants to climb this hill to get more stable. The light elements do it by fusing together, and the heavy ones do it by splitting apart, through fission. And right there, at the very peak, the king of the stability mountain is iron 56. But here's where it gets really mind-bending. This simple, two-dimensional curve, well, it's hiding a profound geometric secret. Because if you map it in just the right way, it literally unfurls into the exact geometry of an Einstein-Rosen bridge. You know, a wormhole. Look at this. Suddenly you have two funnels. The one on the left, that's fusion, the elements made inside living stars. The one on the right, that's fission, the elements made when stars die. And connecting them right there at the narrowest point, the throat, is iron, the most stable point in the entire universe. So we have this cosmic wormhole map. Now for the real test. What happens when we plot the elements that life actually uses onto this map? Well, what we find is absolutely stunning. They don't just scatter randomly. They snap into a perfect three-part structure. Just take a second to look at that pattern. It's incredible. The elements that are essential for us to exist, they form three totally distinct, non-overlapping zones. And get this, these zones perfectly line up with what they actually do in our bodies. It is just way too neat to be an accident. Let's start with zone 1, over on the fusion side of the bridge. These are the builders. We're talking about the big ones: hydrogen, carbon, nitrogen, oxygen, plus crucial players like calcium for our bones and potassium for our nerves. These are the elements forged in the core of living stars, and they make up more than 99% of the atoms in your body. They're the literal bricks and mortar. Now, let's go right to the center, to the throat of the wormhole, the most stable place in the universe. This is where we find the engines. This is our catalytic core. Iron, carrying oxygen in our blood, copper and zinc, making respiration happen. We only have tiny, tiny amounts of these, but they are the super high-performance engines that run our entire biochemistry. And finally, over on the other side, the fission side, forged in the beautiful chaos of dying stars, we find the regulators. Things like iodine, which runs our metabolism through the thyroid, or selenium, a key part of our antioxidant defense. These aren't building blocks or engines. They are the delicate, fine-tuning switches that keep our complex systems in balance. Okay, I know exactly what you're thinking. A three-part structure, that's kind of neat, but is it really meaningful? Which brings us to the most important question of all. What are the odds that this is all just one big, beautiful coincidence? So is this amazing pattern, especially that perfect lineup of all the biological engines right at the throat, is it just a fluke? A lucky roll of the cosmic dice? Well, the math has a pretty loud and clear answer, and that answer is no, not even close. When the researchers ran the statistical analysis, this is the probability value they got. So what does a number like that even mean? It means the odds of this pattern showing up by random chance are about 1 in 100,000.
To put that in perspective, in physics, this is what's called a 4.7 sigma effect. That is way past the level for strong evidence and is getting very close to the gold standard for an actual discovery.
And this graph shows you why those odds are so insane. These gray bars show it happened in 100,000 random computer simulations. On average, you'd expect about 2, maybe 3 essential elements to land in that throat zone just by luck. But the actual number we observe in life? 8. Every single one of them. It's a massive outlier. It's screaming at us that something fundamental is going on here.
A pattern this improbable, it strongly suggests we're looking at something more than just chemistry. And this has led researchers right to the edge, to the frontier of this whole idea. Could this cosmic map actually tell us something about one of the biggest mysteries in all of science, consciousness itself?
If we zoom right into the throat of this bridge, one specific isotope just pops out from all the others, iron-57. It's not just in the throat, it's sitting in the most stable, most central, most privileged position on the entire map. And this little guy is special. It is the only nucleus at the throat that has a quantum property called spin 1/2. You can think of that as the purest, cleanest possible magnetic state. It basically makes it a perfect quantum probe, a tiny little compass sitting at the absolute heart of our biochemistry. Okay, now hold that thought and let's consider a puzzle. The element xenon. Chemically, it's an inert gas. It doesn't react with anything. And yet, it's one of the most powerful anesthetics we know of. It can completely turn off consciousness. And where do we find it on our map? Right here, on the fission side, sitting right next door to the throat. So you have this incredible duality. On one side, there's iron-57 right at the throat, whose special nuclear spin might enable quantum processes in the brain. And on the other side, its neighbor, xenon, an anesthetic whose ability to work is actually disrupted by nuclear spin. It raises a stunning possibility. Are we looking at a quantum on-off switch for consciousness, with its mediator and its disruptor sitting right next to each other on this cosmic map? And that leaves us with this one absolutely profound question. Is it possible that the very same geometry that dictates how stars live and die also provides the fundamental quantum blueprint for consciousness itself? The pattern is right there, written in the elements, just waiting for us to fully understand it.